Okay, so question number one. The table summarizes these results. So the table summarizes results from 979 pedestrian deaths. So, right there, that were caused by automobile accidents. I think we've dealt with a problem like this before. So there's 979 pedestrian deaths caused by automobile accidents. So let's make sure the table's making sense for you first. Tell me about these 61 people. What do we know about them?
Both the pedestrian and the driver were intoxicated.
Yeah, well said. Both the driver and the pedestrian were intoxicated. Say yes, yes. Driver intoxicated, yes. Pedestrian intoxicated, yes. Right? So among all 979 deaths were a pedestrian, a person walking. It's kind of sad, huh? Person that's walking got hit by a car and died. So they weren't even in a car. They're a pedestrian. Out of those 979 cases, in 61 of the cases, both the driver was intoxicated and so was the pedestrian. In 282 cases, the driver was not intoxicated, you see, but the pedestrian was. That's probably the pedestrian's fault. They were maybe walking out in the freeway or doing something crazy, but the driver was not intoxicated. In these 69 cases, the driver was intoxicated, but the pedestrian was not. So in that case, the driver is probably to blame because they were drunk and the pedestrian was not. So maybe the driver did something crazy, drove up on the sidewalk or something. And in these 567 cases, which is the majority, right, most of them, neither person, it was a no and a no, neither the driver nor the pedestrian were intoxicated. Nobody was drunk, and yet somehow still a pedestrian was hit by a car and died, sadly. All right, so if one of the pedestrian deaths is randomly selected, so if we pick one at random out of these 979 that are in this table, find the probability that both the pedestrian and the driver were intoxicated. So that's what they're asking us. What's the probability that both the they do the, let me back up. Both the pedestrian and the driver are, well, here, I'll just put it right here, intoxicated. So what's the probability that both the driver and the pedestrian are intoxicated? Remember how probability works. You've got to put the total on the bottom, don't you? And so what is the total? It's the 979, right? This is out of 979 cases. So if we were just to grab one case at random, that's what they're saying down here, right? If one of the pedestrian deaths is randomly selected, so out of these 970, if we were to grab one at random, what's the probability, what's the chances that in that case we randomly, if we just randomly grab a file out of a bunch of files, what's the chance, out of 979 files, what's the chance that we would get one in which both the pedestrian and the driver were intoxicated? What am I going to put in the top?
61.
Yeah, the 61, huh? Good job. The 61, because that's the yes and yes. Here, right here, I'll say both yes, which is the 61. That's right. That's exactly what we want, because we want both the driver and the pedestrian intoxicated. That's 61 people. In 61 of the cases out of 979, they're both intoxicated. So if we divide that in our calculator, I'm doing it right now on my calculator, I'm getting 0.062308. Now we're supposed to, notice it says, please enter decimal to 4 places. We got to round to 4 places. So you put the line after the 4th place there. And so that means 0.062308. 2, 3. Is this good? Is this making good sense?
Mr. Harriet, how if the